Hi Year 11 Mathematics Advanced students. Today we're continuing on with the topic of Introduction to Calculus, but today we're learning about the product rule. So the product rule is a method for differentiating the product of two functions. So for the product rule, we have if u and v are functions of x and y equals uv, so that means u and v are multiplied together, where u and v are functions, then we have dy on dx, so the derivative of y with respect to x, equals v times du on dx plus u times dv on dx. Or we have y dash equals u dash v plus v dash u. So let's have a look at some examples. So let's differentiate y equals 3x minus 5 in brackets times 2x squared minus 4x plus 1. Now I'm going to use the I'm going to use y dash equals u dash v plus v dash u. They're exactly the same rule, it's just that our u dash equals our du on dx and our v dash equals our dv on dx. So this is just the shorthand way of writing it, and it's a way that I have been accustomed to. So we have y equals our function, so we have our u equals our first bracket, so 3x minus 5, and we have our v equals our second bracket, our 2x squared minus 4x plus 1. So now what we want to do is we want to differentiate u and differentiate v. So the derivative of u, so of 3x minus 5, is just 3, and the derivative of v, so 2x squared minus 4x plus 1 is going to be 4x minus 4. We now want to substitute these four values, so u, v, u dash, and v dash, into our equation. So we have our, we don't like our y's today, so y dash equals our u dash v plus our v dash u. So our y dash equals our v dash, which is 3, times our v, so 2x squared minus 4x plus 1, plus our v dash, which is 4x minus 4, times our u, which is 3x minus 5. So now we have some expanding and some collecting of like terms. So we have y dash equals 3 bracket 2x squared minus 4x plus 1. So we're going to multiply our 3 in. So we have 6x squared minus 12x plus 3. Plus we're going to expand our brackets for our 4x minus 4 times 3x minus 5. So 4x times 3x is 12x squared. 4x times minus 5 is minus 20x. Minus 4 times 3x is minus 12x. And minus 4 times minus 5 is plus 20. So then we are going to collect like terms. So we have 6x squared plus 12x squared. So that equals 18x squared. Then we have our minus 12x minus 20x minus 12x. So minus 12 minus 20 minus 12 equals minus 44x. And then we have our constants, which is plus 3 plus 20, which will equal plus 23. And so that is the derivative of our function we were given. Moving on to part B. So again, I'm going to use y dash equals u dash v plus v. Oh, this pen. Plus v dash u. So we have that our u equals our 9x cubed, so our first term, and our v equals our 2x minus 7. So then we need to find our u dash. So our derivative of 9x cubed is going to be 27x squared. So we bring our power of 3 down and multiply it by the 9 to get our 27, and decrease our power of 3 by 1 to get the power of 2. And then for our v dash, we have 2x minus 2, where 2x minus 7, where our derivative of 2x minus 7 is just 2. So then we're going to substitute these into our y dash equals u dash v plus v dash u. So we get our y dash equals our u dash, which is 27x squared, times our v, which is 2x minus 7, plus our v dash of 2 times our u of 9x cubed. So now we need to either expand our brackets or basically multiply. So 27x squared times 2x is going to get us 54x cubed, and 27x squared times negative 7 is minus 189x squared, plus 2 times 9x cubed is 18x cubed. So then we can collect our like terms. So we've got our cubes, so our 54x cubed plus 18x cubed, which gives us y dash equals 72x cubed, and then minus 189x squared. And that's how we differentiate using the product rule. We also can use the product rule together with the chain rule, which we have learnt last lesson. So we want to differentiate y equals 2x to the power of 5 and 5x plus 3 all cubed. So again, we're using y dash equals u dash v plus v dash u. So what we want to do is we say that our u is our 2x to the power of 5. We have our v equals our 5x plus 3 all cubed. Our u dash is our derivative of 2x to the power of 5. So we bring our power of 5 down and multiply it by our coefficient of 2. So 5 times 2 is 10. X to the power of 5 minus 1 is 4. So we drop the power by 1. And then our v dash, this is where we use our chain rule. So we bring our power out the front. So 3 times our multiplied by our bracket. So 3x plus 5. 5x plus 3, drop our power by 1 so that it's 2, and then multiplied by the derivative of our bracket, which is 5. So then we have v dash equals 3 times our 5 is 15, bracket 5x plus 3 all squared. So then we can substitute these into our y dash equals u dash v plus v dash u. So we will have y dash equals our u dash, which is 10x to the power of 4, times our v, which is, which is 5x plus 3 all cubed, plus our v dash of 15 bracket 5x plus 3 all squared, times our u of 2x to the power of 5. So now we need to multiply, we don't need to multiply in our brackets for our first term. So we're going to leave it as 10x to the power of 4 by 5x plus 3 all cubed. We are going to multiply our 15 by our 2x to the power of 5 though. So this will be plus our 15 times 2 is 30x to the power of 5. Bracket 5x plus 3 all squared. And then when we stop there, you can notice that in our brackets we have the same thing. We have the 5x plus 3. In one bracket we have cubed, and in one bracket we have squared. And so we're going to bring that out the front. But what we're also going to bring out the front is we can divide, we have our 10x to the power of 4 multiplying that, and we have 30x to the power of 5, which if we take a common the common factor of 10x to the power of 4 out, we can do that too. So I'm going to just break it down. So we have y dash equals 10x to the power of 4, bracket 5x plus 3 cubed, plus 10x to the power of 4 times 3x, bracket 5x plus 3 all squared. So again, we see that our 5x plus 3 is the same, and we see that we've now created the 10x's to be the same. So we can take a common factor out the front of 10x to the power of 4, bracket 5x plus 3, and it will be just squared because we have the lower power is squared, but that means we'll have a 5x plus 3 left over. So then we multiply this together. So we have our 5x plus 3, which is what we had left over, plus our 3x, which was also left over. So we get our leftovers. So we had one of them left over and our 3x, which was plussed on. And we put them in their own bracket and collect like terms. So we have y dash equals 10x to the power of 4, bracket 5x plus 3 all squared, times 5x times plus 3x, to collect like terms, is 8x, plus our constant of 3 in our bracket. So that's a bit trickier as you have those extra steps at the end and you can take the common factor out the front. Moving on to B, which is our last example, we have y equals 3x minus 4 in brackets times the square root of 5 minus 2x. So for this one, we are going to write it in the form of y dash equals u dash v plus v dash u. So our u is our first term, which is 3x minus 4. Our v is our second term, which is the square root of 5 minus 2x, but we want to write this in power form. So v equals 5 minus 2x to the power of a half. So then our u dash is just going to equal 3, because the derivative of 3x minus 4 is just 3. And then our v dash is going to equal, bring our half out the front. So again, this is the chain rule. Times our bracket, which is 5 minus 2x. Subtract 1 from our power, so it will be minus a half, and multiply by the derivative of our bracket. The derivative of our bracket is minus 2. So then we have v dash equals a half times minus 2, which is just minus 1, times 5 minus 2x, all to the power of negative a half. And so we know that our 5 minus 2x to the power of negative a half equals 1 over the square root of 5 minus 2x. So that means v dash equals minus 1 over the square root of 5 minus 2x. Okay. So then we can substitute these into our equation. So we have y dash equals u dash v plus v dash u. So we have our u dash is 3, so it will be y dash equals 3 times our v, which is our 5x minus 2, or our 5 minus 2, sorry, minus 2x to the power of a half, plus our v dash, which is minus 1 over our square root of 5 minus 2x, times our u, which is 3x minus 4. So then we have y dash equals 3 square root 5 minus 2x minus, now when we this minus here makes this a negative, and then we want to multiply our 1 by our 3x minus 4, so that means our numerator will become 3x minus 4 all over the square root of 5 minus 2x. And we're not done because we would like it all to be over the same bottom and actually to be one fraction. So what we're going to do is we're going to multiply this term, our first term, by 5 minus 2x, or square root of 5 minus 2x. So then we will have y dash equals root 5 minus 2x times the square root of 5 minus 2x minus, and that will be all over root 5 minus 2x minus our 3x minus 4 over our root 5 minus 2x. So then y dash equals 3 times root 5 minus 2x times root 5 minus 2x is just root 5 minus 2x all squared. So that actually cancels out the square root. So we just are left with 5 minus 2x minus our 3x minus 4 all over our denominator of 5 minus 2x. And I've run out of room, so I'm just going to come up here. So now we need to multiply our 3 into our brackets. So we'll have y dash equals 15. So 3 times 5 is 15. Minus 3 times negative 2x is negative 6x. Minus 3x minus 4 in brackets. So that minus will make this minus 4 a positive. So there is the brackets here around that, all over the square root of 5 minus 2x. So then y dash will equal, collecting like terms, 15 plus 4 is 19. And then minus 6x minus 3x is minus 9x. All over the square root of 5 minus 2x. And that is it. So it's really important that we simplify our derivative down to the